Hello students, welcome to Ant's classes. Let's do area of a trapezium and a polygon, exercise 22b. Question 11. A path of uniform width 3 meters runs around the outside of a square field of side 21 meters. Find the area of the path. Okay, so now we have a figure like this. Now here they are saying there is a path here. Can you see the lightly shaded portion? Now that is the path and the width is 3 meters on all sides. It's 3 meters. Now this runs outside of a square field. So this is the square field and the path is outside the square field and the side of the square field is 21 meters. Now we have to find the area of this path. So first we have to find the area of this square excluding the path. Then we have to find the area of this square including the path. Then when we subtract both, we will get the area of the path. So let's begin by saying length of the square field PQRS is 21 meters. Area of this field excluding the path will be side square, isn't it? Area of a square is side square and side is 21 meters into 21 meters. So we have to multiply both. 21 into 21 is equal to 441. So this is 441 meter square. So we have found the area of this portion alone now, and this is excluding the path. That's why we have written area of this field excluding the path. So without including the path, we have found the area of this. Now we are going to find the length of the square field including the path. So only after finding the length can we find the area, isn't it? So length of the square field including the path is 21 meters is the length here. This much is 21 meters. Now this portion is going to be 3 meters and this portion is also going to be 3 meters. So altogether we can get the length of this side AB. So that is 21 meters plus 3 meters plus 3 meters. So that is equal to 21 plus 3 is 24 plus 3 is 27. So now we have the length of the square field including the path. So now let's find the area of the field including the path. Again, it is side square. So that is equal to 27 meters into 27 meters. That is 729 meter square. So now we have found the area of the field excluding the path and then we have found the area of the field including the path. Now we are going to subtract the two areas. So area of the path will be area of the field including the path minus area of the field excluding the path. So now let's substitute here. So area of the field excluding the path is smaller as you can see. So we're going to put area of the field including the path first. So that is 729 meters square minus area of the field excluding the path, which is 441 meters square. Now we need to subtract these two. When we subtract, we get 288 meters square. And what have we found? We have found the area of the path. The area of the path is 288 meter square. Question 12. A path of uniform width 2.5 meters runs around the inside of a rectangular field 30 meters by 27 meters. Find the area of the path. Okay, let's understand this. So this is the figure. A path of uniform width, that is, this grey portion is the path and it is 2.5 meters on all sides. That's the width. Now this runs around the inside of a field. So this is the rectangular field and the path is inside the field. And the measurements of that rectangular field is given length and breadth. Now we are asked to find the area of this path. So again, first we have to find the area of the rectangle that is outside including the path. Area of the rectangle including the path. Then we have to find the area of the rectangle excluding the path and subtract the two answers. So let's begin by saying length of the rectangular park. We're talking about the length of the park including the path. So this is the length and it's given to us as 30 meters. So this is 30 meters. Now the breadth is also given to us. It's 27 meters. Now we have to find the area and the area is length into breadth. And length into breadth means 30 into 27. That is 810 meters square. So we have found the area including the path, that is area of this rectangle ABCD. Now, the width of the path is given to us. Let's make a note of that. The width of the path is 2.5 meters. Now, what is the length of the path excluding the path? Okay, so this is the length. Now we have to leave out these two. So what is that length? Because we have not been given this length. We have only been given the width. So this 2.5 meters is only the width of this path, but we don't know the measurement of this rectangle. But we are told the length of this rectangular path, we can get it by minusing this length and the 2.5 centimeters. That is, we can take 30 meters minus 2.5, that is on one side, again minus 2.5. Now why am I minusing it twice? This much is one portion. If you add this and this, you get this one, isn't it, AB? So if we have to find the length of this, we have to subtract 2.5 meters from both sides. So to subtract this, now 30 minus 2.5 becomes minus 5. So 30 minus 5 is 25. So we have found the length of the rectangular path, and that is 25 meters. Now we have to find the breadth, isn't it? Now this is the breadth. Again, this one is excluding this, isn't it? So we take the whole of 27 minus 2.5 minus 2.5. So let's do that. So the breadth will be 27 minus 2.5 minus 2.5. I hope you understood how we got that. See, this whole thing is 27. If we have to find only this much, it should be 27 minus this portion, which is 2.5, minus this portion, which is 2.5. That's how we got 2.5 twice. So here also it's 27 minus 5. 27 minus 5 is 22. So we have the breadth, which is 22 meters. So now we have the length and the breadth. We can find the area excluding the path, that is length into breadth, which is length is 25 meters, breadth is 22 meters. So when we multiply these 25 into 22, we get 550 meters square. So now we have two areas. Area including the path is 810. Area excluding the path is 550. If we subtract the two, we will find the area of the path. So area of the path is equal to area of the field including the path minus area of the field excluding the path. So including the path, the area was 810 meters square, and excluding the path, the area is 550 meters square. Now let's subtract both. We get 260 meters square, and this is the area of the path. Question 13. The length of a hall is 18 meters and its width is 13.5 meters. So from this you can make out that the hall is rectangular in shape. So let's get that. So we have a figure just to help us understand better. The length is 18 meters. It's given to us in the question, 18 meters, and the width is 13.5 meters. Now, what are we asked to find? Find the least number of square tiles, each of side 25 centimeters, required to cover the floor of the hall. That means we have this floor, hall, and the floor of the hall is going to be covered by square tiles. And each square tile is going to be 25 centimeters each side. So here, this is one square tile. That means the side is 25 centimeters. Now another tile will be placed next to it. Similarly, this will be filled with tiles. We are asked to find the least number of square tiles. We need to find how many tiles are needed to cover the floor with, look at the first question, without leaving any margin. There's no margin here. Without leaving a margin, we're going to put all the tiles. So we need to see how many tiles are needed. Along with that, we are also asked to find the cost of the tiles. So after we decide how many tiles are needed, we're going to find the cost of the tiles required at the rate of 6 rupees per tile. For one tile, it's going to be 6 rupees. Okay, so here first thing we need to do is we have to find the area of this rectangular floor. Then we have to find the area of each square tile. So let's begin by saying length of the hall is 18 meters given to us. Breadth is given 13.5 meters. Now area is length into breadth, and length is 18 meters into breadth is 13.5 meters, and that is equal to 243.0 meters square. So we can just leave out that 0.0 and write 243 meters square. So what did we find? We found the area of the floor of this rectangular hall. So we found that. Now each tile, length of each tile or the side of each square tile is 25 centimeters. Remember, all these are in meters. We are going to convert the centimeters to meters. We know that 100 centimeters make 1 meter. So 1 centimeter will make 1 by 100th of a meter. Now here we are talking about 25 centimeters. So 25 centimeters will be 25 by 100 meters. So let's write it here. So this is 25 by 100. We can reduce this to the lowest form. So this becomes 1 and 25 into 4 is 100. So this is 1 by 4 meters. So what have we found? We have found the side of each square tile in meters. Now, why did we convert this to meters? We did that because here the area of the floor we found out in meters square, isn't it? Now the area of the tile also should be in meters square. So now let's find the area of one tile side square. Side is 1 by 4. So side square will be 1 by 4 into 1 by 4. And this is equal to 1 by 4 fours are 16 meter square. Meter square. So now we need to find the least number of square tiles required. So how do we do that? We say area of the floor divided by the area of the tile. That will give us the number of tiles. So area of the floor is 243 meters square. Area of one tile is 1 by 16 meters square. So area of the floor we already found out to be 243 meters square. This is the area of the floor. Area of one tile we found to be 1 by 16 meter square. Now we are going to find the number of tiles required. That will be area of the floor divided by area of one tile. So area of the floor is 243 meter square there, divided by area of one tile, that is 1 by 16. So this becomes 243 into 16 by 1. So we have to multiply these. This is multiplication of fractions, so nothing to cancel. So we multiply 243 into 16 by 1. We get 3888. Now this is the number of tiles. So number of tiles required is 3888. Now we are asked to find the cost, isn't it, of these tiles. So we begin by saying rate of the tiles is 6 rupees per tile. Each tile is 6 rupees. That means to find the total cost, we have to say number of tiles. Now we know number of tiles is this into the rate, which is 6 rupees. So number of tiles is 3888 into the rate, which is 6 rupees. So we have to multiply these two. And when you multiply, you get 23,328. So we have answered the first question. First question, we have found the number of tiles required, 3,888, and we also found the cost of laying these tiles, 23,328. Now we continue. Now the second part of the same question, here they're saying leave a margin of width 1.5 meters all around. So first we're going to do that. We're going to leave a margin of 1.5 width all around. So here we have this rectangle and we already know the length is 18 meters. The breadth is 13.5 meters. And now we've been asked to leave a margin inside and then arrange the tiles on it. So that means if we leave a margin, we get a space like this. And this is 1.5 meters, not 25, 1.5 meters, this space. This margin here is 1.5 meters all around. It says all around, so all around it is 1.5 meters. So in question 1, we did not leave a margin, isn't it? Now in question 2, we are leaving a margin and then arranging the tiles. So when we arrange the tiles, we will have the tiles like this. There's one tile here, there's one more tile here, and then everywhere tiles are arranged. As you can see, this time the number of tiles will be lesser than the previous one, isn't it? Because of the margin that has come. So now we are going to again begin by saying the width of the margin is 1.5 meters. Now, the inner length, we are talking about this inner length. Inner length is this much, isn't it? And the outer length is 18 meters. So how to get the inner length? 18 meters minus this much, which is 1.5, minus this much, which is 1.5. So inner length is 18 minus 1.5 minus 1.5. So this is 18 minus 3. 1.5 minus 1. Here when you add up these two, it becomes 3. So this is equal to 15. So the inner length is 15 meters. Similarly, the inner breadth also. Now breadth is 13.5 meters for this rectangle outside. If you want to find the inner one, we take 13.5 and minus 1.5 here and 1.5 here. So this becomes 13.5 minus 1.5 minus 1.5. So this is 13.5 minus 3. So that becomes 10.5. So this is 10.5 meters. Now we have the inner length and the inner breadth. We can find the inner area. So the inner area will be length into breadth, which is 15 meters into 10.5 meters. And this is equal to 157.5 meter square. So now we have the inner area of this hall. After leaving a margin, we have the inner area, and we know the area of one tile. We found out in the previous question, the area of one tile is 1 by 16. 1 by 16 meters square. We found this out in the previous one. Now we're going to find how many tiles are required. So the inner area is 157.5 meters square. The area of one tile is 1 by 16 meters square. Now to find the number of tiles required, it is inner area, that is 157.5 divided by area of one tile, which is 1 by 16. Now since this is division of fractions, we can convert it to multiplication and write the reciprocal. 157.5 by 1 into 16 by 1. So here we have to just multiply 157.5 into 16. So when you multiply, you get 2520. So this is the number of tiles. So we know now the number of tiles required if you leave a small margin. Now we also have to find the cost. To find the cost, remember the rate of the tile. One tile is rupees 6 per tile. So if we have to find the total cost, we say total cost is number of tiles, which is 2520, into the rate, which is 6. So multiply these two and we will get our answer, and the answer here is 15,120. So this is the total cost of laying these tiles at the rate of 6 rupees per meter. Question 14. A rectangular field is 30 meters in length and 22 meters in width. So let this be the rectangular field, and that is 30 meters in length and 22 meters in width. Now, two mutually perpendicular roads. I hope you know the meaning of perpendicular, that is cutting another line at right angles. Two lines which cut each other at right angles are called mutually perpendicular lines. So here we are talking about two mutually perpendicular roads. So here can you see this is one road, this is one road, and they are mutually perpendicular because they are cutting each other at 90 degrees and each is 2.5 meters wide. So the width here, that is this width, is 2.5 meters. And these two roads are drawn inside the field so that one road is parallel to the length of the field. So this road is parallel to the length of the field and the other road is parallel to the width of the field. Now we have to calculate the area of the crossroads. This is called the crossroads. We have to find the area of the crossroads. So what we have to do here is find the area of this road and find the area of this road. But can you see there is a square here in between which will overlap, because when you find this you're including this portion also. When you're finding this you're including this portion also. So 2 times this area is going to be calculated. So what should we do? We have to find the area of only this square. Find the area of this overlapping square and subtract it from the other 2 areas. We'll do it slowly and carefully. Length of the rectangular field is given to us as 30 meters and the breadth we know is 22 meters. Now, width of each road is also given to us as 2.5 meters. That is, this road is 2.5, this is also 2.5. So here it will be 2.5 meters. Then area of the first road. So let's take this as road 1. So this is going to be road 1. Area of the first road is length into the width of the road. So length is this, the same length. See, this is parallel to this. So this is the length, 30 meters. Into width is 2.5 meters. So this will be 30 into 2.5. And that is 75. So this is 75 meters squared. This is the area of the first road. Now, area of the second road, let's take this to be the second road. This is the second road, road 2. So here length into width. This time the length is 22 meters. Length of this is 22 meters. Width is the same. So length into width. So length is 22 meters into the width, which is 2.5 meters. So multiply the two and that will be 55 meters square. So now we have found the area of the first road. We found the area of the second road. Remember, there's a square in the middle which is being counted twice. So we have to find the area of this and minus it from there. Minus it from these two. Okay. So now let's continue. So here, area of the overlapping square. We have to find the area of the overlapping square. For that, we need the length and breadth, isn't it? So the width of the road into the width of the road. So how did we get that? Now this width is 2.5. It's the same here. This is 2.5. And it's the same thing here. It's the same thing here. Similarly, this part is 2.5. It's the same thing here also. So the square is 2.5 into 2.5. That is width of the road. So 2.5 into 2.5 will give us the width of the road. When you multiply these two, we will get the area of the overlapping square, and that is 6.25 meter square. Next, to find the total area of the crossroads, what should we do? We should add up area of road 1 and the area of road 2 and minus this area of the overlapping square, this square. So let's do that. Area of road 1 we found out to be 75 meters square. Then the area of road 2 is 55 meters square. This also we found out, and we are going to minus the area of the square, the overlapping square, which is 6.25 meters square, which we just found out, meters square. So 75 plus 55 is 130. 130 meters square minus 6.25 meter square will give us the total area of the crossroads. And that is 123.75 meters square. So what have we found? We have found the total area of the crossroads to be 133.75 meters square. Question 15. The length and breadth of a rectangular field are in the ratio 5:4 and its area is 3,380 meters square. Find the cost of fencing it. Now here we are talking about fencing, and fence is something you put in the border, isn't it, or the boundary. That means we have to find the perimeter. We've been given the area. So we have to find the perimeter and then the cost of fencing it at the rate of 75 rupees per meter. So now let's begin by saying let the length of the rectangular field be the first term of this ratio, that is 5x. So length, let it be 5x. That means the breadth can be 4x. And we've also been given the area of the field, which is 3,380 meters. Now we know the formula for the area of the field, and that is length into breadth. And length into breadth is already given to us how much it is. 3,380 meters square. Now how much is length? We said let length be 5x into breadth, and breadth we said let it be 4x. Together it will add up to 3,380 meters square. Now 5 fours are 20, x into x is x square. 20x square is this 3,380. Therefore, x square will be 3,380 divided by 20. So here we can cancel, and this also we can cancel 1, and this will be 169. So x square is 169. So what will x be? X will be the square root of 169. And what is the square root of 169? It's 13. 13 into 13 is 169. So we have found the value of x. Now x is 13. We are going to substitute it here and here to find the length and the breadth. So the length is 5x, which is 5 into x, which is 5 into 13. 5 into 13 is 65. So the length is 65 meters. And the breadth is 4x, that is 4 into x, or 4 into 13. And 4 into 13 is 52 meters. So now we have the length and the breadth. And now we can find the perimeter first. So let's do that. To find the perimeter, now let's use the formula 2 into length plus breadth. So 2 into length is 65 meters, breadth is 52 meters. So this is 2 into 117, and that becomes 234 meters. So we have found the perimeter. Now that we have found the perimeter, it's going to be easy to find the total cost of fencing. So what is the rate given to us? The rate of fencing is 75 rupees. So the rate of fencing is 75 rupees, and the cost of fencing, the total cost, is perimeter into rate. And how much is the perimeter? 234 into rate is 75 rupees. So when we multiply this 234 into 75, we get the total cost, and that is 17,550 rupees. So this is our final answer. Question 16. The length and breadth of a conference hall are in the ratio 7:4, and its perimeter is given to us. First, we have to find the area of the floor of the hall. So let's consider the length of the hall to be the first term of the ratio, that is 7x. And then the breadth also, let the breadth be 4x. Now what is given to us? The perimeter is given to us as 110 meters. We know the formula for perimeter, 2 into length plus breadth, and that will be equal to 110 meters. So that is 2 into length is 7x plus breadth is 4x, and together all this will give us 110. Now let's simplify this. 2 into 7x plus 4x is 11x, will give us 110. So 11x is equal to 110 divided by 2. So we can cancel here. 2 ones are 2, 2 into 55. So 11x is equal to 55. So x will be equal to 55 by 11, and that when you cancel, you get 5. So this is the value of x. Now with the help of that, we can find the length and the breadth. So length is 7x, and we have found the value of x to be 5. So that is 7 into 5, 35. So length is 35 meters. Now the breadth is 4x. That is 4 into 5, because x is 5. 4 5s are 20 meters. So now we have got the length and the breadth. We can find the area of the floor, and that will be length into breadth. So let's area of the floor of the hall is equal to length into breadth, and length we found out to be 35 meters, and breadth we found out to be 20 meters. So 35 into 20. 35 into 2 is 70. So we add one more zero and meters square. So now we have found the area of the floor of the hall, and that is 700 meters square. Second part of the same question, we have to find the number of tiles. Each a rectangle of size 25 centimeters into 20 centimeters required for flooring of the hall. So we've been given the measurements of the tile, of each tile, and now we have to find the number of tiles. That means we have to find the area of the tile, and we already know the area of the floor, and together when we divide we will get the number of tiles. So area of the tile is 25 centimeters into 20 centimeters. As we know, here we found the area in meters, isn't it? Meter square we found. So we are going to convert the centimeters into meters. So that will be 100 centimeters, as we know, make 1 meter. So 1 centimeter will be 1 by 100th of a meter. 1 centimeter is 1/100th of a meter. So here we need to find 25 centimeters. That will be 25 by 100 meters. Similarly, 20 centimeters will be 20 by 100 meters. So let's substitute it here. So here let's write 25 by 100 into 20 by 100. This is the area of one tile. So here we can cancel. 25 ones are 25, 25 into 4. Here 20 ones and 20 into 5. So now let's multiply the numerators. We have 1 and below we have 5 fours are 20. So now we have found the area of one tile to be 1 by 20 meters square. We have converted it to meters. So now this is 1 by 20 meters square. Now to find the number of tiles, we say area of the floor divided by area of one tile. Area of the floor we found it out to be 700 meters square divided by area of one tile, which is 1 by 20 meters square. So this is 1 by 20 meters square. So now this is division of fractions. So let's convert it to multiplication. So 700 by 1 into, and let's write the reciprocal, 20 by 1. 7 twos alone you multiply first. 7 into 2, it's 14. Then add all the zeros. There are 3 zeros, 1, 2, 3. So now what have we found? We have found the number of tiles, that is 14,000 tiles. So this is the answer to the second part of the question. The third question here, we have to find the cost of the tiles at the rate of 1,400 rupees per 100 tiles. So this is per 100 tiles. So rate is rupees 1,400 per 100 tiles. That means we write it like this, 1,400 by 100 per 100, isn't it? So 1,400 by 100. Then the number of tiles we know is 14,000. Now to find the total cost, we say number of tiles into the rate. So number of tiles is 14,000 into the rate, which is 1,400 by 100. So here we can cancel. We can cancel these two. So we have to multiply 14,000 into 14. First let's multiply 14 into 14. 14 into 14 is 196. 196. Now there are 3 zeros. Let's add the 3 zeros. 1, 2, 3. So now we have found the cost. The total cost is 1,96,000 rupees. So this is the cost of the tiles at the rate of 1,400 per 100 tiles. So this is our final answer. With this, we come to the end of our exercise. Thank you, children.